Struggling with inter-service communication in your microservices architecture? In this video, we tackle real-world challenges of building a robust e-commerce application, focusing on issues like latency and data consistency during peak loads. Learn how to design scalable, efficient systems that handle these challenges with ease. 1. Minimizing latency. Asynchronous communication. Use message brokers like Kafka or RabbitMQ for asynchronous communication between services. For example, when an order is placed, the order service publishes an event to Kafka and other services. Examples: payment service, notification service, consume the event independently. This decouples services, reducing the need for synchronous requests and preventing bottlenecks during high traffic. Load balancing. Employ load balancers. Examples: AWS Elastic Load Balancer, Jinx, to distribute incoming requests evenly across service instances. This ensures services remain responsive even during peak loads. Caching. Use caching. Examples: Redis, Memcached, to store frequently accessed data, such as product details or user session data. Reducing calls to the database and service dependencies. Efficient API design. Optimize API endpoints to reduce latency. Batch multiple requests into one when possible. Use pagination for large data responses. 2. Ensuring data consistency. Event-driven architecture. Implement an event-driven architecture using tools like Kafka. For example, if a user places an order, services handling the order, payment, and inventory update consume the same event and process their respective tasks independently. Use idempotency in event handling to avoid processing duplicate events. Saga Pattern. Use the Saga Pattern to manage distributed transactions. For example, in a multi-step operation, examples: order creation, payment, inventory update. If one step fails, example: payment fails, the previous steps, example: order creation, are rolled back. Choreography. Each service reacts to events from other services. Example: inventory reacts to order events. Orchestration. A central coordinator service handles transaction workflows. Consistency verification. Implement periodic consistency checks. Use tools like Debezium for real-time monitoring of database changes. Verify data synchronization across services during off-peak hours. 3. Scalability during peak loads. Autoscaling. Deploy services in a containerized environment like Docker orchestrated by Kubernetes. Configure Kubernetes Horizontal Pod Autoscaler, HPA, to scale services dynamically based on CPU, memory, or custom metrics like queue length. Database optimization. Use read replicas for databases to offload read operations. Partition the database, sharding, to distribute data across multiple servers. Graceful degradation. Implement a graceful degradation strategy. If certain services are overloaded, prioritize essential features. Example: allow users to browse products but temporarily disable recommendations. 4. Proactive monitoring and alerting. Observability tools. Use tools like Prometheus, Grafana, and ELK Stack to monitor latency, throughput, and error rates in real time. Implement distributed tracing. Examples: Jaeger, Zipkin, to identify bottlenecks in inter-service communication. Alert mechanisms. Set up alerts for latency spikes or service unavailability to respond proactively. 5. Redundancy and fallbacks. Use circuit breakers, examples Resilience 4J, Hystrix, to prevent cascading failures. If a dependent service is slow or unavailable, the circuit breaker will return a fallback response. Example: service temporarily unavailable. Employ retries with exponential backoff to handle transient failures. By employing these strategies, the architecture can handle peak loads efficiently, minimize latency, and maintain data consistency, ensuring a robust and seamless experience for end users.